Right, afternoon all. Hope you're all well. Welcome to a network architecture for semester two. As far as today's session is concerned, I think we're just going to be looking at obviously what the module is all about and just understanding exactly what's happening, especially from an assessment point of view, what is expected of you in terms of submissions and the actual content itself. And then probably just revisit some of the content that we literally briefly discussed in our computer architecture module, just understanding exactly what's happening with the network and the different components, naturally, that you're obviously supposed to be familiar with, and just understanding exactly how to properly configure. And again, like I said before, right at the beginning, just basic introductory content associated with the actual module at large, and just understanding exactly from obviously a personal and professional point of view what a networking is distinctively all about. So we're just going to look at what's happening with the module, what module purpose is all about, and then obviously the different learning units that are there. And again, like I mentioned before, just also looking at what is happening as far as assessments would distinctively go. So if you look at your screen currently, this is what the module purpose is all about. So your module outcomes, about 4 of them that are there. Like I was just saying a couple of seconds ago, just looking at basic concepts of what networks are all about, what is the underlying architecture, looking at the whole concept of the different components, obviously, that enable us to create and configure a successful network, the different media platforms that are there, obviously understanding things like topologies and protocols, which are obviously distinctively relevant as far as ensuring an appropriate network platform there is concerned. So if you look at the module outcomes there, again, like we mentioned before, just a basic structure, looking at how to install, configure, and obviously troubleshooting. I think it's very important for you to realize that whenever you look at anything ICT, really, especially from or an architecture point of view, one of the core things that you're supposed to be familiar with and literally supposed to be good at is being able to successfully troubleshoot any distinctive environment. So that's obviously being able to identify a distinctive problem and ensure that you fix it or resolve it accordingly. And then obviously, just like we were mentioning a couple of seconds back as well, the different components and basic tools that you'll need to use as far as your network environment there is concerned. Now, if you look at the assessments, structure is still one and the same. I think we're all familiar with what's happening with ICE. And like I've mentioned, especially when you're looking at our computer architecture module, this is a very practical module. Yes, we'll have a couple of theory-based sessions naturally for us to obviously be able to relate the practical part of the module at large. So literally every research-based content that I give you, please treat that as ICE. As you can see, there are a minimum of 4 activities that need to be completed, but literally the more activities that you complete, the better chance you get for obviously getting that or the total mark associated with allocation per se. So your research, your revision-based questions, some tasks that are obviously largely practical in a certain sense, obviously will need to be completed accordingly, just to ensure that not just for mock allocation, but obviously to enable you to understand exactly what's happening with module content and to be able to assist you, especially from a professional point of view, as far as understanding exactly what's happening with concepts there. And then from a formative point of view, you've got 2 distinctive tasks that are there. So this is a POE-based module, not obviously to be taken for granted. I think I've discovered a lot of candidates tend to kind of take a bit of a back seat when it comes to POE-based modules. I think there's a general misconception that we've got enough time, or content is distinctively simple. So most individuals don't really take it seriously, but it can obviously hoodwink you if you're not careful, because it's a practical module. There's a lot of content that you obviously need to take into consideration there, and ensure that everything is done accordingly. I think your PAS should be up on the portal. If not, it should be up soon. Just to make sure that you diarize the actual due dates associated with these particular submissions, just to avoid any discrepancies that might arise. And like I've said before, I think it's imperative for you to at least submit a couple of days before, as opposed to the actual due date. Remember, they give you these dates for you to actually plan accordingly. So try and avoid actually trying to complete these tasks either a night or so before the actual due date, just to avoid any problems that might arise. Remember, from a technological point of view, you might experience glitches as well. So if an assignment is or if a task is due at a specific date, like I always mention, advocate for at least a week or so before the actual due date arrives. That's when you're supposed to literally submit these distinctive tasks, just to ensure that we all on the same page. Then, obviously, because it's a practical type of task, you also want to make sure that you've got everything that you need at hand before the actual time arises there. So you've got task one and task two. I think the actual POE is not yet on your portals. I think the last time I checked was sometime yesterday. If there's a bit of an update, give me a heads up. But if not, I think it should be up soon. Then we'll just have a quick discussion on that as well as the time arises, in order for us to make sure that we're all sorted. So in terms of the demarcation there, task one, 25%. Task two, 30%, and then obviously the actual POE itself, 35%. The overall mark that guarantees your pass is 50%. And like we've mentioned a couple of times before, if you're sitting between 40 and 48, then you qualify for a resubmission of that POE, but unfortunately it will be capped at 50%. And then if you're outside the confines of those mark allocations, then unfortunately that might mean that you need to actually repeat the module. So we want to avoid that at all costs, as far as the actual module at large there would go. So if content remains the same, obviously when you look at it from year in, year out, content and obviously submissions and actual types of POEs might change. But if they don't, then what we are literally looking at is virtualized platforms that would require us to install a client and obviously install a server as well, and try and look at these two entities as a minimum, being able to communicate and literally create our own type of network, especially within a virtualized environment. So what that would mean is, from a hardware point of view, actually from a system point of view, both the hardware and software related, it means that you need to have a machine that obviously has a processor that can accommodate for virtualization. So that's one very important aspect. And then when you're looking at the RAM configuration there, your minimum RAM literally should be 8 gigs of RAM. All right, anything less than that can be detrimental in terms of proper functionality or the snappy response of your machine at large. It doesn't necessarily mean that your environments won't function, but you will have massive difficulty in terms of having these virtualized platforms accommodated for accordingly. Because remember, if you remember what's happening with computer architecture, we mentioned virtualization before, and we've said that with virtualization, you obviously have the host, which is the physical machine. And then you've got your virtualized platform where you're literally loading a machine within another machine. So both the physical and the virtualized platforms are literally working on one entity. All right. So if you're sitting with for argument's sake, the 8 gigs of RAM, and you load two more machines in your virtual environment, it means that you've got you can split the RAM accordingly. There, 4 for the actual host, which would be the physical machine, and then 2 apiece for the virtual machines that you've got running in your environment. So if you've got less than 8 gigs of RAM, that becomes a bit of a cumbersome process in terms of running those virtualized platforms accordingly. I think you also might have had this discussion as well, possibly with your CNOS lecture as well. From a practical point of view, in terms of assessments, that you also need to ensure that you're literally going to be running a virtualized environment. So please ensure that when it comes to the machines that you're using, the processors need to accommodate for virtualization. And then you also need to be sitting with at least 8 gigs of RAM. And then when it comes to your storage, SSDs, typically your default go-tos, but traditional hard drives will still work accordingly. At least have about 100 gigs of free space. So you can obviously play around with that in terms of installing the virtual machines if need be. So just take cognizance of that fact when it comes to the actual technology that you'll need. Right. And then the other thing as well that you also need to take cognizance of, especially when you're looking at it from the software point of view, at least be running Windows 10 Professional on your machines, because instead of using the third-party virtualization software, such as VirtualBox, for argument's sake, if you're required to use Hyper-V, which is the inbuilt, which is one of the direct configurations you find from a virtualized environment for the Windows environments, you will need to at least be running Windows 10 Professional to accommodate for that, because Home, unfortunately, does not allow for your Hyper-V configurations or virtualization platforms if you're looking at it directly. So just ensure that obviously when it comes to the OS as well that you're running, your Professional would be a default go-to. I doubt if 8.1 is applicable, but should you be sitting with 8.1, again, same difference applies, that at least it should be the Professional version of that, just to avoid any discrepancies there. So from a software point of view, that's what you're distinctively looking at. So just ensure that you're sorted in that regard. So again, those are your 4 main setups when it comes to assessments: your ICE, the 2 TOS, and ultimately your POE. Like I mentioned before, if your PAS is not up yet, it should be up soon. Then make sure that you take cognizance of the dates. Should those dates obviously change, like you've already experienced in the previous semester, then naturally what it means is the campus will give you a heads up in that regard, in terms of those distinctive changes as far as your specific setup would go. So you've got about 9 learning units associated with this particular module. Yes, we will be looking at obviously content that is relevant in that regard, but more of my focus is obviously going to be on the TOS and the POE, so more practical inclination when it comes to the actual module at large, to ensure that when it comes to the 2 TOS, when it comes to the actual POE, we've got enough acumen to ensure that we complete these particular assessments accordingly. So yes, we will look at the different aspects, especially I think what's more important is just understanding how to function a virtualized platform, how to look at configuration of server architectures, for instance, understanding what's happening with your IP addresses and the assignments, and then also distinctively looking at it from a security point of view as well. How can you secure your networks, or try and make them more secure to avoid any unauthorized access or any discrepancies that might arise with unprotected systems. And then naturally also looking at the standards that we were mentioning a couple of moments ago when we were looking at the actual overview as far as the actual module there would go. So the more of the focus is obviously going to be on the practical part, just to ensure that from our own personal and professional spaces, we are familiar with the network configurations and obviously how to deploy these particular networks accordingly. And then when you look at the learning units at large, so the first learning unit, which is some of the content we're going to be looking at today, just basic fundamentals of networking, understanding exactly what's happening with what actually a network is. What are the different components that make up a network? What's happening with the difference between data, signals, the whole concept of transmission and so on as distinctive aspects. So that's what your first learning unit is going to be looking at. Naturally, the different types of network components, also looking at comparison of the different types of networks that are there, and then understanding and realizing the actual trends that you'll find within organizational setups, especially when you're discussing network topologies, and then obviously the different emerging technologies that are out there as far as your particular setup is concerned. So that's the first learning unit. And then when you look at the second one, standards and models, I think this also makes it a lot easier for us to understand exactly what takes place in the background when you're looking at sending and receiving messages across different components within an actual network itself. I think we've mentioned this superficially in previous sessions before, that obviously when you're looking at communication, there has to be some kind of standard that avails for that communication to take place successfully. So this is what this particular learning unit is actually distinctively looking at, and looking at the different models that are there. I think one of the most important ones in terms of understanding what's happening is the OSI model, or the Open System Interconnect model, also working hand in hand with the TCP/IP model. All right, so there's going to be a lot of talk in terms of protocols, just understanding what they are and how they assist in proper network configuration, and then also introducing and discussing IP addresses, right? So understanding exactly what's happening with an IP, how do you configure these accordingly, what are the different versions of the IP addresses that are out there, and how relevant are they when it comes to distinctive configuration. So obviously, this also assists with troubleshooting your networks accordingly without any distinctive issues there. And then when you look at the third learning unit, again, still delving into the whole concept of protocols. Again, what you're distinctively looking at there is just discussing what are the roles of these distinctive protocols when it comes to network access, and basic advantages and disadvantages, or pros and cons of things like LAN access when it comes to your distinctive environment there. So just understanding exactly what is imperative and how relevant it is within your distinctive environments there. And then after that, you're obviously going to be looking at the different types of network architectures that distinctively exist. So again, this comes to the whole issue of evolution of the different network configurations that are in existence or that have been in existence, and just understand the actual importance of proper planning when you're laying out a network, when you're designing a network, when you're configuring a network. If you look at it from a different point of view, what are the actual best practices when choosing a specific type of network architecture in your distinctive environment? I think it's also important to understand that the sizes of the networks are also imperative in a specific instance. Why? Because that determines the type of gadgets or type of components that you'd use, the type of architecture at large that is going to be incorporated in your environment. So for instance, if you're going to be setting up a small home office, or you're setting up something at home, for instance, that the size of your particular network is obviously going to be a lot smaller as compared to something that you set up on campus, for argument's sake, or that you set up when you're connecting to different buildings within the central business district of a specific locality, for argument's sake. So what you're looking at there is the different components that you'd use, obviously the different standards, the different architectures that are configured within that specific environment there. So that's your learning unit number 4, which is your network architectures. And then when you look at the 5th one, you're looking at the design and implementation now of your network configurations there. Again, it's always important to understand that before you actually physically connect, you literally need to look at, for lack of a better expression, a dry run of what the network would literally look like. So this is part of the design process, right? So you actually laying out connectivity on paper, for argument's sake, and looking at how your devices or components are going to be communicating within your distinctive structure before you actually physically lay out your or install your cable or install your network or install your wireless configuration, whichever way you look at it. So it's imperative for you to look at what type of design techniques you obviously need to take into consideration and how important it is in terms of making sure that when you actually end up physically laying down the actual network itself or incorporating or installing the network, you don't run into any hurdles as far as a setup would go. So just understanding exactly what's happening with physical network infrastructure and obviously how you would look at deploying that network itself. I think one of the things as well that you are supposed to familiarize yourself is that with networks, you've got logical and physical parts. So the logical part of a network, literally, especially, I think you'll discover this when we discuss topologies at large. Normally, when you discuss the logical part of a network, you're literally looking at how the network functions, right? And then the physical part is how the network seems, or how the network is connected, if you want to look at it from a different point of view. So what you actually can physically see is a typical example of the physical part of a network, a specific router, for instance, connected to a server using a cable, and then that particular server connected to another router or connected to a switch for the internal network as a typical example. It's something that you can literally see cables running from one end to the other, physical components connected in whichever way necessary. But then at the end of the day, there's the logical way in which that network is configured, which means, or which literally indicates the way in that particular network functions. So logical function, and then physical, how it seems, and then your network media and basic devices. So here, just looking at different types of networking gadgets or infrastructure, if you want to look at it from a different point of view, why they're relevant and how they assist and aid in proper configuration of your distinctive network. And then when you're looking at the layout of a network, all right, this is what your topologies are. So your topologies are just the basic layout of your network. And again, like I was mentioning a couple of moments ago, there's a physical topology and then there's a logical topology. The physical is what you can see or how the network seems. And then the logical, like we mentioned before, is how the actual network functions itself. So normally you might discover that you can configure a topology in a specific physical format that functions way differently in the logical environment there. So it's important to understand, first of all, what the different topologies out there are, and obviously how they can be reconfigured to function in a different way as they are distinctively physically connected, if you want to look at it from a different point of view. And again, I think it's very important or very difficult for us to discuss anything to do with networking without delving into the wireless part of it. So remember, your generic network initially back in the 60s, there was a basic physical connection between one distinctive machine to the other. So obviously using a cable or using some kind of physical link, and your cable is the default. But ultimately, with the advancement of tech, and naturally, wireless communication was distinctively designed, makes it a lot easier for you to look at connection between entities without having to actually physically lay down a cable, for argument's sake. So it's important to understand what are the different wireless architectures that distinctively exist. I think you'll discover that Some of this particular content, again, mentioned in computer architecture, but we're going to be delving into it slightly more in depth, just for you to understand exactly, strictly from a networking point of view, how these particular entities function. So understanding what's happening with Wi-Fi, understanding what's happening with your wireless access points, for instance, and the obviously common devices that are distinctively suitable for wireless networking. And I think that also introduces cloud computing as well, just understanding what's happening in that regard and why it's distinctively relevant there. So there's a management platform that is also necessary. Being able to manage your networks is something that can literally goes without saying. Just making sure that you protect network resources, either by using your anti-malware packages or anti-intrusion architectures like your intrusion detection systems or intrusion prevention systems. Just making sure that when you look at for instance, that AAA that we've mentioned before, your authentication, authorization and auditing, for instance, that you've got mechanisms put in place that ensure that a specific individual or logs into the system and only does what they're supposed to do. Should they not, you've got mechanisms put in place to try and curb unauthorized access of certain parts of the network or certain content within the network, whichever way you look at it. So that's obviously part and parcel of management. I think you can also even discuss security at large in that regard. And you'll discover that most of the content across all three modules, from CNOS to ICYS and network architecture, that there's going to be content that literally overlaps. So arguably from a security point of view, understanding exactly how to secure your environments is ultimately important as well. I think if you've been paying attention when it comes to what has been going around globally, there's been a lot of security breaches across the board. I think from our own internal perspectives, I think Transnet was hacked a couple of weeks ago. Again, it's imperative for you to understand what measures could have been put in place to try and avoid that, or try and obviously detect it while it was happening or before it happened, whichever way you want to look at it, and what mechanisms you put in place for the disaster recovery of the after effects of that particular attack. And I think, again, also a couple of weeks back, I think it was reported in the media there that the president's phone was also jeopardized from a security point of view. What mechanisms could have been put in place in that regard to try and avoid such a scenario, or to try and identify or detect it again, either while it was happening or before it happened? Those are some of the things that you also need to look at as far as configurations would go. So this is all part and parcel of networking as well, because remember, it's very difficult for you to arguably hack into a specific system if you are not part and parcel of a network, or if you don't log onto some kind of network in order for you to get that access, or in order for you to literally have that distinctive link. So that's also part and parcel of what's happening as far as network management is concerned. So those are the 9 learning units at large associated with the actual module itself. But again, like I said before, while we're going to be touching on most of this content, I think the main focus is also being for you to be able to actually understand exactly how this all gels in a practical point of view, and obviously how relevant it is for you to obviously successfully complete the tasks at hand, as well as successfully submit your POE, as well as successfully understand exactly what it is that you're doing, so that obviously when you move into your own professional spaces there, you get an understanding of what is happening in that regard. So that's the actual module at large. As far as basic content there is concerned. And again, like I said before, what we'll be looking at as far as today's session would go is just discussing what a network is all about, and what type of configurations are necessary, especially from an introductory part, for you to get an added understanding, and also discussing the different components that are relevant in basic network configuration there. All right, so let's see if we can quickly create our notes as we go along, and then we'll entertain any questions towards the end of the actual session itself. All right. Okay, so when you're looking at network fundamentals, right, it's imperative for you to, again, like you said before, just understand exactly what the network is all about, first of all, and then move on to look at how you can successfully implement it as far as configurations would go. So we are discussing a network, right? And a network is literally an interconnection of two or more computer systems with the associated peripheral devices, obviously for the purposes of sharing resources. So sharing resources. And remember, these resources can either be hardware or software related, right? So sharing resources, so either from a hardware point of view or from a software point of view, whichever way you want to look at it. And then secondly, what you're distinctively looking at is just basic communication. Right. So that's the basic concept of what a network is all about. So interconnection of two or more computer systems with the associated peripheral devices for the purposes of sharing resources that are either hardware or software related, and ultimately communicating. But remember, the moment you look at the whole concept of communication at large, there has to be some kind of uniform platform that enables successful communication to take place, right? And that uniform configuration that you've got when it comes to your networks is your protocols, right? So the term protocol is more or less the same as a universal language, right? So it's something that enables proper communication on a physical platform as well as the logical platform when you're looking at your networks at large. And ultimately, all you're looking at in this particular instance is that it's just some kind of rule or procedure that governs communication across the board. That's what a protocol is. And you've got different types of protocols that exist that allow for this uniformity to distinctively take place. So with a protocol, all you're distinctively looking at is a rule or a distinctive procedure that governs communication. That governs communication, obviously, in your networks, right? So just mentioned networks there. So this can either be distinctively from a physical point of view or from a distinctive hardware environment. And obviously, we've got different examples that you can typically put across. I think we've used the SIM card slot as a typical example before, that obviously no matter where a phone is manufactured on the planet, the SIM card slots are always the same. Why? Because you are sticking to a standard. Nano SIM, mini SIM, micro SIM, you name it, but there's a specific standard that is stuck to. So that obviously the telecommunications industry organizations, when they create these particular SIM cards, there's a standard that they distinctively stick to in terms of configuration, shape, and size. You name it. You can even discuss such content as your USB slot as a typical example of physically based protocols. You can also talk about the 3.5 millimeter jack. And then when it comes to your abstract protocols or your non-physical protocols, if you want to look at it from a different point of view, your IP addresses or your internet protocol addresses, your hypertext transmission or transfer protocol, is another example of an actual abstract protocol that is stuck to obviously avail for universal access of content, universal communication across the board. So it's very important for you to take cognizance of that distinctive fact that without these protocols, it makes it very difficult, if not literally impossible, for you to successfully configure any type of network. So if you're looking at the network interface card, for instance, and you're discussing a basic Ethernet cable, if these NICs are not configured in a universal or uniform fashion, then obviously the physical connection between one computer system to the other, or between a computer system and an actual central networking device, becomes literally impossible, and the whole concept of the network becomes null and void. So it's very imperative for you to understand the whole concept of what's happening in that regard, as far as configurations would go, and look at the whole concept of these protocols. And we're going to be discussing them, like I was mentioning a couple of moments ago when we were looking at the different learning units, a lot more as we go in depth as far as the actual module content there is concerned, just understanding exactly which type of protocols need to be used in which environments, and obviously how they affect the appropriate communication across the board. So you can also even find certain literatures using the terms protocols and standards interchangeably, because remember, when you're looking at a standard, you're just looking at something that is distinctively uniform, or that is stuck to across the board when it comes to configurations in that regard. So it's also important to understand the different components that distinctively look at enabling us to configure your networks. But again, if you want to look at it from a different point of view, I think before we even look at that, I was just mentioning that one of the most important protocols is the IP or internet protocol that you'd find as far as your networks are concerned. So this is distinctively short for internet protocol. And you've got two distinctive versions that are relevant as far as configuration would go. So you've got IP version 4, which is distinctively a 32-bit address. And then you will also have IP v6, which is a 128-bit address. Right. So this just distinctively looks at again an address that uniquely identifies a machine within any given network. So remember, in order for you to be able to send and receive your messages, for argument's sake, literally, in order for there to be some kind of identification of entities or gadgets within that network, they have to have some kind of uniform address, or they have, or rather, unique address. And that unique address normally is identified by your internet protocol configurations there. IPv4, most common IP address format that you find, but obviously because of limitations in the actual size and the total number of IPs within that distinctive environment, IPv6 was designed to accommodate for that a limitation or discrepancy. But we're obviously going to be discussing those in a bit more detail in the subsequent sessions that arise. So this is just an entity that enables unique identification of a gadget or device on a network. If a device does not have an IP address, then obviously it can't communicate with any other component within your distinctive environment there. So just take cognizance of that distinctive fact in terms of the actual protocols that exist within your environment. You can also even discuss MAC addresses, although these are now physical addresses for every network interface card that is out there. And if you want to look at it from a different perspective, your internet protocols are typical examples of logical addresses that are available for routing, or that are available for mapping of movement of packets from one particular machine to the other, or one particular node or component to the other. And then at the same time, your MAC addresses are now a typical example of physical addresses that distinctively identify the physical component that avails for that network connection, which is normally your network interface card. So both physical and wireless within that regard. So when you're looking at this particular setup, I think it's imperative for us to just mention that this is a typical example of a logical address. And then at the same time, if you're looking at it from a physical point of view, you've got a MAC address. And remember, MAC is distinctively short for media access control. And this is a typical example of a physical address. So normally this is incorporated on the actual network interface card as far as your configurations would go. So this identifies the actual computer system or node as far as your configurations would go. And then your MAC address is typically associated with your network interface card environments there. So it's a typical example of a physical address, and the other one is a logical. I think you'll see exactly what we mean when we're discussing the OSI model in tomorrow's session, when we're looking at the different types of standards and models that distinctively exist. So one of the other things as well that is imperative to understand is that when you're looking at when you're discussing computer architecture, more often than not, if not literally all the time, data is identified as raw facts and figures, or something that doesn't have any meaning. Why? Because naturally it needs to be processed first in order for you to get information, which is a meaningful substance. So generically, data from computer architecture's point of view is identified as raw facts and figures, right? When it's raw, obviously it means that not processed or unprocessed. And then when you process that data, if you want to get, or if you need to actually get a meaningful substance, you need to process the data and you get a meaningful substance, which is typically information. But when you look at it from a networking point of view, different schools of thought would mention data as something that is as a meaningful substance that you're actually sending from one particular machine to the other, or that literally translates to a message, or literally translates to whatever entity that makes sense in that regard. But again, it's very important for you to understand that when you look at the whole concept of your networks, there's a distinct difference between data and signals. Right? Signals are the means by which we send data. And obviously data is that meaningful substance if you want to look at it from a distinctive point of view. So if you want to look at it from a basic perspective, your data is the actual entity, all right? So here, let's mention entity. And then your signal, let's mention means, right? So in essence, what it means is the data has to be converted into a signal for transmission first, right? And then obviously at the receiving end, the reverse is true. So ultimately, data has to be converted obviously into a signal for transmission, right? So this is very important for you to distinctively remember, right? So data has to be converted into a signal for distinctive transmission. And then as far as the actual signals there are concerned, you've got different types of signals that exist, right? You can either have analog or digital signals. So these signals can either be analog. All right, so analog is more or less you can mention that as your generic voice platforms there. And as far as that particular analog signal, you can also mention that this falls in the category of electromagnetic frequencies. Is that the right spelling there? I doubt it. Frequencies, right? And then you will also have, so normally you find that these electromagnetic frequencies are normally identified in that wavy format, right? And then on the other hand, you will have digital. And not to confuse you, that digital is normally as identified with your data. And this particular setup is identified as a voltage, pulses. And if you're looking at diagrammatic representation, normally you find something along these lines, where the bottom part is normally identified by a 0 there, and the top part represented by 1. So normally you'll discover that when you're looking at the whole concept of these particular signals there, from an electronics point of view, we've mentioned this before, 0 normally represents an off state or insignificant state, and then 1 represents an on state or significant state, if you want to look at it from a different perspective. So this is the relationship as well that you need to remember and understand, especially at a core level, as far as your particular configurations would go. Just understanding exactly what's happening with the IPs or logical addresses, physical addresses, and just looking at the whole concept of data being a meaningful substance within a network environment, and obviously needing conversion into a signal in order for propagation across any particular link that you've got. So whether it's a bounded or wireless connection that you've got, this particular data has to be converted into a signal first before it can be sent to its desired destination as far as configurations would go. So on that note, it's also important to identify some of the basic devices that are associated as far as your generic networks would go. So it's imperative for you to understand that, remember, when you're looking at that connection we were talking about early on, the whole issue of communicating and sharing resources, that these particular networks can either be bounded or wireless. So when it's bounded, it means that you've got a physical link between the two, or between one or more entities, or two or more entities, whichever way you want to look at it. And then if it's a wireless, there is a link between, but there's no physical connection that you've got, if you want to look at it from a different point of view. So these networks can either be bounded or wireless. Right, so just remember that when it's bounded, you're actually using a physical cable, and then when it's wireless, the link is there, but you're not. There's no physical link between the actual configurations that are there. So when you want to look at the distinctive devices now, in this regard, you can discuss such items as your NIC, or your network interface card, and literally this is the same as a network adapter, if you want to look at it from a distinctive point of view. And then you will also encounter slightly archaic, if you want to look at it from core networking perspective, or perspectives, there is a hub, right, which is literally a connection device that allows multiple connections to a network. But in all honesty, one of the main discrepancies associated with hubs is that they are not secure because they tend to broadcast. And at the same time, there's a speed issue, because the more devices that you plug in, the more the speed is shared across the actual devices that are there. So just for argument's sake, if you're sitting with 100 megabits per second as a configuration, you plug in more devices, or you plug in a lot, or let's say 4 devices or 5 devices, if you want to look at it from a different point of view, when you're using a hub as a central networking device, then literally what it means is you've got limitations in the maximum amount of speed that is available for transmission as far as these devices are concerned, because it's literally shared across. So you can literally get a maximum of 20 instead of the 100 that you initially wanted there. So this is a typical example of a very basic networking device, but again, to be more specific, if you're looking at core networking, it's not a device that you'd want to use because of those distinctive issues there. So with a hub, central networking device, so just for argument's sake, when we're saying central, this also goes into the whole concept of the topologies we were discussing earlier on, but just briefly, or that we mentioned, we're mentioning that this could be your hub, and then you obviously have your different devices that literally connect, all right? And 1, 2, and 3 could be computer systems, inclusive of a printer, for instance. But again, like I mentioned before, the speed is a bit of an issue, and it's a broadcast perspective, because if one is communicating with 4, for instance, 2 and 3 can tap into that communication because there's no security or dedicated comms, if you look at it from a distinctive perspective as far as your particular setup is concerned. So it's part and parcel of a central networking device. So I think it's important to remember, again, that the more devices you plug in, if you're going to be using hub architectures, the worse your network becomes in terms of speed and generic security as far as your specific setups there are concerned. And then when you, so here, I think we can mention the whole concept of a speed issue. Speed, or we can just say speed is shared across, and then it broadcasts communications. Come on. So it broadcast communications there. All right, so this is one of the discrepancies that you'd find. But then to alleviate that particular issue, especially when you're looking at your localized area network configurations, a switch was distinctively designed. So your switch now alleviates the speed issue. So no matter how many devices, if you've got a 48-port switch, you plug in 48 devices, speed is still applicable there. 24-port switch, the same, different supply. So there's dedicated communication, so it's obviously more secure, and then the speed is not jeopardized. So it literally works within the same vein as a hub generically, but literally more sophisticated because it allows the control and management of data transmission. So normally you find that when you're looking at these particular setups, you're literally designing local area networks, all right, or your LANs. So this obviously goes into the different sizes of networks that distinctively exist. So the moment you want to then connect two different networks or connect to an external network, if you want to look at it from a different point of view, what you now have as a generic device would distinctively be your router. And your router also deals with logical addresses. So in essence, if you're looking at your modeling architectures, your hubs, your switches, physical addresses, or within the physical environment or layers, and then your router is now responsible for enabling communication to or with external networks. So that's what your router would be, something that a device that connects two or more networks that obviously outside the confines of physical locality there. So if you want to look at it from a different point of view, your routers would obviously deal with logical addresses as far as your specific setups there are concerned. You also identify certain terms as gateway, bridges, and routers, which is a gateway is literally one and the same as a router, because literally it enables you to connect to an external network. It provides a gateway to an external network, if you want to look at it from a different perspective. And then a bridge can be used to connect two or more physical networks. So this is when you're looking at the actual physical infrastructure we were talking about a little earlier on, as opposed to logical. And then the router is just a combination of what the bridge and the actual router distinctively offers in your setups there. So these are some of the generic devices that you'll obviously find as far as your configurations would go. I think it's also imperative for us to discuss your servers as well. And remember, we mentioned that your servers are these dedicated machines within a networked environment that are responsible for specific services in that distinctive network. And a typical example of these particular services could include such content as email, for instance. You can talk about print. You can discuss web. You can mention proxy. You can also even discuss app. The list will go on and on in terms of the different types of a service that exist. And I think part and parcel of the actual POE would require you to configure a service. So install service software and then configure it accordingly. So you'll discover that the software that is associated with configurations at large is, if you're looking at it from a network setup perspective, you've got what they call network models, right? And when you discuss network models, you've got a client-server architecture, and then you also have peer-to-peer configurations. So with the client-server architecture, you've got computer systems or PCs that are normally called clients that connect to a central or to a single machine or a dedicated machine that is known as a server. And that server is responsible for providing specific services to these given clients. So obviously, when it comes to the actual software at large that you install, it means that on the clients, you're installing client operating systems. This is where CNOS comes in now. So that's your Windows 10 as a typical example, is what you would install on these clients or these machines. And then on your server, right, that single dedicated machine that is responsible for these particular services that we've just listed on this slide, you will need to install a network operating system, right? So Windows Server 2016 is a typical example of a network operating system that has been distinctively designed to work on a machine that is responsible for providing different types of services within a network environment, be it email, be it print, be it application, be it web, be it proxy, be it your distinctive authentication service. It all depends. So remember, when you walk onto campus, you go into one of the computer rooms. When you sit on the machines in one of the computer rooms there, those machines are running client operating systems, Windows 10 as an example. And then when you log in, you're actually logging onto the network. But what enables your particular electronic credentials to be verified is obviously going to be a specific type of dedicated machine, which is your authentication server. Right? What is it responsible for? Making sure that it verifies the electronic credentials that have been entered at a client workstation. And if these electronic credentials are correct, verified accordingly, you're granted access to the network and the system. And obviously, when it comes to what you can do on the system, but you've got the infrastructure is obviously put in place in terms of permissions associated with a specific account or with a specific user. You've got a dedicated type of domain controller or a network controller, if you want to look at it in a different point of view, that is responsible for knowing what a specific user is supposed to be doing on the system, and obviously what a specific computer system or specific gadget is allowed to do on the system. So this is where your Active Directory comes into play there, especially when you're discussing your Windows-based platforms. So if you're looking at it from a different perspective, it's important to understand what these models are all about and what they distinctively provide for. So I think the next thing that you want to look at, I think from a device point of view, these are the basics. Yes, you might want to find other literatures mentioning such components as your modems, for instance. But I think we've mentioned before that that's now obsolete or archaic architecture, if you want to be very specific, because your modem, which is short for modulation, demodulation, its main purpose was to convert digital signals that were coming from the computer system to analog, so that they could be traversed or transported across a telephone line, which obviously dealt with voice. And then at the receiving end, it's a reciprocal process. You've got another modem that then converts your analog back to digital so that the receiving computer system can understand. But now, because we're dealing with digital networks, that whole issue of conversion from analog to digital and vice versa is no longer literally relevant when it comes to communication there. So this is where you'd find your dongles as a typical example of certain terms that refer to these wireless communication platforms that obviously enable connection to some kind of network, the internet being your default go-to. So that whole concept of the term modem is now literally basically null and void in that regard. So when it comes to the actual setups, probably before we look at the different models that distinctively exist, I think it's important to look at the different sizes, which is the different sizes of these networks. All right, so remember when you determine the size, you've got two main types of sizes that are there. You've got a LAN, which is short for local area network. And this is obviously within the confines of a distinctive geographic space. So something that you configure in a specific computer room, for argument's sake, or something that you configure at home, or something that you configure within an educational setup, like we've got on campus, is a typical example of a localized area network because you are within the confines of a distinct geographic space, right? But the moment that you go beyond those confines, then you now create a wide area network. If you find, for instance, two campuses connecting across two cities, that's typically an example of, or across two municipalities, if you want to look at it from a different point of view, then that literally becomes a wide area network because you're now literally looking at it within or looking at going beyond the confines of a defined geographic space. So now the other thing is when you're looking at it from that perspective, as far as basic communication would go, more often than not, these networks exist in hybrid architecture. So you don't just have one distinctive link from one particular entity to the other, but you can also even argue that if you look at, for instance, the biggest wide area network you can discuss, or the another term would be your global area network. What you're literally having is multiple local area networks that are now communicating or connecting at a global scale to create that massive global area network. Some might also even want to call it the internet. So it's important to understand that they don't exist as lone entities in that regard. And different examples of these local area networks that you can find is personal area networks, right? When you connect your Bluetooth headsets to your phone, to your tablet, for argument's sake, you've created your own personal area network in that regard. Something that you've got configured in an educational setup would be a campus area network. Something that obviously we've got on campus is a typical example of a type of local area network. And then these local area networks obviously can be configured with wireless configurations or wireless architectures. This is where the WLAN comes in, which is short for wireless local area network. And then the other type of main type rather of network that you find in terms of the sizes is your wide area network. And obviously, as far as that day is concerned, we can discuss something that is connected within the central business district of a locality or within the municipal area of a specific locality, which is your metropolitan area network. And then you can also even discuss what we were mentioning earlier on, which is a global area network, something that is configured obviously on a global scale. Again, some might want to argue that this also speaks to the internetwork as far as these generic sizes there are concerned. So familiarize yourself with that as well. And obviously, what this would do is also enable you to understand what type of devices and gadgets can be used in these environments. So like I was mentioning earlier on with the devices, if you're looking at a local area network, for instance, your switches would be default go-tos that enable connectivity from one particular computer room to the other, from one particular section of your campus to the other, for argument's sake. But the moment you want that particular campus to now connect to the internet, or the moment you want that particular campus to connect to an external network outside the confines of the geographic space we mentioned earlier, then you might want to then add in your routers, which now deal with connecting two networks or more than two networks, obviously, that are not within the same geographic space, if you want to look at it from a different perspective there. So that looks at actual sizes, and then when you discuss the models, right? So looking at the different models that exist, we were just mentioning earlier on the client server and the peer-to-peer environment. So the first type of model you find is peer-to-peer. And as far as this particular networking model they would go, so let's call this a peer-to-peer network. As far as this there is concerned, it's basically a small network, right, in which individual PCs are connected directly to one another, obviously without the use of servers. All right, so in this particular, remember your peer, if you look at it in a different perspective, your peer is your equal. So in this particular instance, every machine that is connected is literally equal to the next one because there's no distinctive roles at that particular point in time. So there's direct communication, and ultimately, if you're looking at it from a different perspective, very small network, normally you find about 10 as your default go-to machines. Some literatures might want to push that number to 20 as far as configurations would go, but normally you're looking at it from your successfully 10 or between 10 and 15. If you want to be pedantic about it. But again, like I said before, most literatures can still push that number to 20 machines that would create a peer-to-peer network. All machines are the same in this regard. So for instance, if you're copying specific content from one machine in that particular network, only at that particular point in time does the machine that you're copying from become your server and you become its client. But obviously, if the roles are reversed, and that machine is now copying content from you, ultimately only at that particular time does your machine become a client, a server rather, and the other machine becomes a client. So you've got no distinctive roles incorporated within this particular infrastructure there. And then the other one that we mentioned earlier on is the client server configuration. So with peer-to-peer, I think it's important to remember that obviously when it comes to your operating systems, you're literally just working with your client operating systems in this regard. So every machine that you've got within a client, a peer-to-peer network is running the same type of operating system. So regardless of one running Windows 8.1, the other one running Windows 10, for instance, both of these are examples of client operating systems, right? Because all the machines within that environment is one and the same. But when you look at your client server network, like we've mentioned before, your client server network, you've got distinct roles now. So you've got a specific client and a specific server in that environment. And what is the client? Like we mentioned before, this is obviously the multiple PCs that you can have within your network that then centrally connect to or that all connect to a central device there that or the dedicated machine that is responsible for the different types of services that it can literally offer. And obviously, when it comes to the operating systems, you've got a specific set of machines, which are your clients, running client operating systems. And then you've got a dedicated machine within that network that is running specifically network operating systems or your server software in that regard. So normally that server is responsible for distributing data and resources to the actual network at large. And then the other one that you also might want to discuss, which arguably can be more of a bit of a proprietary configuration, especially from a Windows point of view, is what they call a directory services network. So directory services network, in this particular instance now, everything on the actual network itself, including the actual users, computers, and shared resources, are maintained in a central or centralized directory, all right, or centralized database. And if you want to look at it from a Windows point of view, this is where the domain controllers and Active Directory architectures come into play. So it's in this particular instance, when you're discussing directory services, it's more or less an enhancement of the traditional client server environment. And these particular networks are literally designed to make managing the rapid growth, obviously, of these networks that include, obviously, a lot of clients, thousands of clients in certain instances, hundreds or even thousands of clients in certain instances, and network users, to make it just a little bit easier as far as management there is concerned. So if you look at what we've got on campus, for instance, just for argument's sake, just by looking at the computer rooms, I think we've got about 30 odd machines in every particular computer room. If you've got 6 of those computer rooms already, you're just running with 180 machines at large there. This is now excluding the admin side. This is now excluding ops side and so on. So when you're running a directory-based platform, it makes management of all those users and machines literally a lot easier as far as your configurations would go. So obviously, when it comes to the software, like I mentioned before, just remember that you've got your client operating systems, all right, which is normally installed on the client PC naturally. And typical examples there would be your Windows 10, and then the server operating system, which obviously is installed on the server, also known as a network operating system, or NOS, which is distinctively Windows Server 2012, 2016 as distinctive examples in that regard. So with certain terminologies, especially when you look at peer-to-peer, you also have Windows versions of these. So in essence, you could also find the term work group, which is distinctively just a Microsoft version of a peer-to-peer network when you look at it from a distinctive perspective in your basic configurations there. So when it comes back, if you go back to the protocols now, you've got so we go back to the actual protocols. Where were we here? Protocol. So let's go back and or let's rather revisit the actual concept of these protocols. You've got what they call low-level protocols. And normally when you're discussing low-level protocols, these, again, the rules and procedures that obviously enable the onset of a network, or that you could say a system of rules of how network connection is distinctively achieved. So this, if you want to look at it from a different perspective, it controls the physical process of data communication. So low-level protocols control physical process of data comms, right? So that's what your low-level protocols are all about. And you've got distinctive examples of these low-level protocols. You can discuss what is known as the token ring. You can also look at ARCnet. And then you can also even discuss Ethernet. These are all examples of low-level protocols there. Obviously, Ethernet defining actually a wired connection within the network. And then the term ARCnet is short for Attached Resource Computer Network. Obviously, this is outdated. It was used back in the 80s. But this is just one example of a low-level protocol. And then you also have the token ring, which is now normally used in your fiber distributed data interface networks, but initially used in your wired communication. Again, a bit of an obsolete type of configuration there, because it was used initially with copper, right? But there's also been adapted into your fiber distributed data interface configurations as far as setups they are concerned. And then you will also find a typical example of a high-level protocols. All right, high-level protocols. And typical examples now, when you're looking at high-level protocols, now these operate in the abstract or non-physical parts and the software level of your network configurations, and what your high-level protocols are all about. So these are rules of how data is actually transferred from one particular device to the other. All right, so operates at the software level and control things such as the format of your message and how these particular messages are obviously broken down into smaller pieces, which are normally known as packets, for them to traverse along your communications channel and then obviously reassembled right at the receiving end, if you want to look at it from a distinctive point of view. And some of the typical examples of these high-level protocols is that they address or they control addressing, they deal with handshaking, which is these are some of the two processes that are used in obviously establishing a connection between computer systems. So addressing is how you identify or recognize components or devices on a network or nodes on a network. And then handshaking is obviously the whole concept of establishing a connection between machines in that regard. So, like I was saying, these particular high-level protocols literally look at the whole concept of controlling message formats or message formatting. And at the same time, also look at the whole concept of addressing and handshaking. So message formatting, addressing, and handshaking. All right, and obviously within that whole concept, you're addressing is the recognition of your devices, and then handshaking is the process literally of establishing a connection between entities there. And a typical example of the different types that exist, Apple Talk is a typical example of a high-level protocol. No longer used though, but gives you an idea. Then you've got IPX, SPX. This is was used normally with your Novell configurations there. Then you've got NetBEUI. MS-DOS and Windows network softwares. And then I think one of the most common ones, which we'll be discussing in a bit more detail in subsequent sessions, is the TCP/IP, which was initially developed for use on the net and obviously currently used by all machines now, regardless of whichever software or architectures that you're using across the board. So it's more of a universal type of protocol that is used across the board. So I think your TCP/IP there is distinctively your default go-to when it comes to your high-level protocol configurations in that regard. All right. I think that looks at that. The other types of so we looked at the old local area network as well, so in terms of the sizes and in terms of configuration. But I think that distinctively does that in terms of configurations there. Do we have anything else? I think that's pretty much that in terms of the introductory part. So what you can for research, I think from a research point of view, I'd want you to look at pervasive networking. What's happening with my spelling? Pervasive networking. All right, what's that all about? And then also look at information services. And then possibly VPNs. And also look at maybe VPNs. Right, so that's your generic research in that regard as far as content there is concerned. So this should do that for us. I think next the next time of our sessions with you is tomorrow. We're going to be looking at we'll look at the actual protocol, so the OSI model, as a typical example of the different standards that are out there that just try and make communication a bit more uniform and universal across the board there. Right. Let's see if we've got any questions coming in on chat there. Quickly unmute your mics if you need to say something. Right. Do we have any questions, contributions, and concerns from anyone on the floor? Feel free to type, use your chat. Alternatively, if you need to unmute your mic, go ahead and do so. Do you have any questions, contributions, or concerns from anyone? Okay. All right. So it looks like we're all good. So I think we're going to call it a day. Thanks for attending. Stay safe. Keep smiling. We'll see you in the next session. Cheers. Raylan, yes, you can send just you can pop me a mail. All right, cheers, guys.